Welcome back, everyone. So today we're going to be starting a new unit, which is trigonometry. And I know that kind of sounds scary and daunting because maybe you've heard some, horror stories about trigonometry, but it's really not all that bad. And if you break down what the word means, trigonometry, it just literally means the study of triangles. Okay, so we're going to be looking at all different types of triangles, but we're going to start off with the ones that are nice and simple and easy for us, ones that we've used before, which is right triangles. Okay, so we're going to be focusing today on how we can use like the Pythagorean theorem to kind of identify different types of triangles. Okay, so if you recall, so we've used the Pythagorean theorem before in class, and we've used it, and you've seen it in middle school and stuff like that. So this is not anything new. So what the Pythagorean theorem says, all right, if I have this triangle here with side lengths A, B, and C, now remember, just kind of breaking down, legs, right, are the non-long side. So anything that basically the two legs or the two sides that make up, I don't know why I put an S there. The two sides that make up the right angle, all right, these are what we call legs. Okay, and they are always the shortest sides. Okay, the C, the long side, is what we call the hypotenuse. Right? And it is the side that is always opposite the 90-degree angle. Okay, and it is always, always, always the longest side. Okay, and again, since 90 degrees will always be the largest angle, right, we know that from our what are they called? I can't remember what they were called. But when we were dealing with triangles before, right, we were, I can't even remember anymore. Anyway, sorry, moving on. That's not part of the point of this. So again, we're going to be studying kind of Pythagorean theorem, which says that if I take the squares of the length of each of these legs, so a squared plus b squared, I add them together, a squared plus b squared, right, they're going to equal c squared. Okay, and that's just the hypotenuse. That's just Pythagorean theorem. And please also keep in mind that that's kind of also the distance formula at the same time. All right. Now, when using the Pythagorean theorem, we kind of stumbled across these ideas of whole numbers. Okay, so what we tried to look at is, okay, well, which values for A, B, and C, right, can whole numbers make a right triangle? Because normally when you're using Pythagorean theorem, you end up with radicals of some sort, or for the lengths of the sides. So are there any of these which they can be whole numbers? And those are what we call, right, Pythagorean triples. And a Pythagorean triple is just a set of three non-zero whole numbers which can make up sides of a right triangle. Now there's tons and tons and tons of different possible sets, but these are the four sets that we're going to look at. Okay, so for some common Pythagorean triples, we have 3, 4, 5, we have 5, 12, 13, 8, 15, 17, and 7, 24, 25. If I apply the Pythagorean theorem, right, I'm going to get that these are always going to equal, so they're always going to create a right triangle. And just to kind of, as an example, if I take 3 squared plus 4 squared, and I want to figure out, does that equal 5 squared? Well, that's 9 plus 16. Does it equal 25? All right, and the answer is yes. 25 is equal to 25. All right, so they make up a right triangle. And you can do that for each one of these triples. Okay, so 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Okay, but now if I just kind of take those and I multiplied each of those side lengths, right, by the same number. So if I multiply them both by 2, all of them by 2, I get 6, 8, and 10. Do those still make up a Pythagorean triple? The answer is, of course, yes. Okay, and you can do that with these, and we're not going to spend time kind of explaining these and showing these. I just want you to understand that these do exist. And these are all of our common ones. So basically what we've stumbled upon is if I take 3, 4, 5 and I multiply them by the same number, that'll always generate a right triangle with whole number values. Same thing with 5, 12, 13, 8, 15, 17, 7, 24, 25. Okay? Now, again, that's assuming that if we multiply them by the same whole number, whole positive real number, so natural number. Okay, and we can use both of the methods to kind of find missing sides of a right triangle. Okay, so if we look at example 1, right, we want to find the missing side length of the given right triangle. So let's just say we have 2, 3, and x. right? So we're trying to find the hypotenuse in this case, right? My longest side. So I know that that's going to be 2 squared plus 3 squared, which is equal to x squared. 4 plus 9, which is equal to x squared. All right, that means 13 is equal to x squared, and x is, and then in order to solve for that, I've got to take the square root of both sides. Okay, so I get x is equal to square root of 13. And we're always going to assume that x is positive. Okay. Another way that we can look at it is we have 16, x, and 20, so we're missing one of the legs. But right, I know if kind of looking back at my Pythagorean triples, right, I have 16, x, and 20, right? Where did you go? All right, 16x and 20, right? We can see that, well, hey, 5 times 4 is 20, 4 times 4 is 16, right? So this is actually Pythagorean triple 3, 4, 5, right? Where it's 3 times 4, which is equal to 12, so my x is going to equal 12, and that'll generate a Pythagorean triple for us. Okay, so again, just different way. If we just kind of recognize that using Pythagorean triples, that's just another way for us to be able to solve for missing missing sides. Okay. Now we have the converse of the Pythagorean theorem, which basically says, hey, you know what? If we have some triangle here with A, B, and C are my sides, and let's just assume C is always my largest side. Okay. All right. So again, I'm going to highlight this. This is going to be largest side. Okay. Then if I prove that a squared plus b squared is equal to c squared, right, then we've actually shown that this is a right triangle. So what we want to do is determine, like using for examples 1, 2, and 3, right, we want to determine if the side lengths make up a right triangle. Okay. So we have 10, 24, 26. Okay. Since 26 is my longest or my largest side, right, this has to be the c squared. Okay. So it'd be 10 squared plus 24 squared. Does it equal 26 squared? Well, 10 squared is 100, 24 squared is 576, and 36 squared is 676. If I add up 105 plus 576, we get 676. Okay. So what we also could have noticed, so yes, this does make up a right triangle. What we also could have noticed is that, hey, you know what? This is actually, right? Whoa, I don't know what just happened there. Hang on. There we go. That was weird. What we could have also noticed is that, hey, you know what? This is a Pythagorean triple. Okay, so 10, 24, and 26 make up a Pythagorean triple. So I know that this guy's got to be a right triangle. Okay. Then look at 2, 2, 2 square root of 2. Again, since this is my 2 times the square root of 2 is obviously going to be greater than 2, that has to be my c. And so then I look at, well, 2 squared plus 2 squared, does it equal to rad 2 squared? And that's 2 squared is 4, so 4 plus 4, right? And then whenever I square this, remember this is this remember your power rules. Okay, so if I take this whole thing to a power, this is 2 times 2. This is the same thing as going, well, that's 2 squared times square root of 2 squared. Okay, square root of 2 squared is simply just 2, and 2 squared is 4, so it's 4 times 2, which is 8. Okay, so 8 does equal 8 in this case. And so they make a right triangle. But even more so since these two are, oh, sorry, it keeps doing that. Since these two are the exact same, right, we know that this is actually an isosceles right triangle. Okay. Looking at number 3, 2, 3, 4. Well, 4 is my largest side, so this has to be my c, my greatest side. And so I look at 2 squared plus 3 squared, does it equal 4 squared? Well, 4 plus 9 is equal to 16. Well, 4 plus 9 is 13, not 16. So they don't make a right triangle, right? But do they make a triangle in general? Okay. So one of the things that we want to recall is our triangle inequality theorem to determine if we even have a triangle. Okay. So since we know that for 2, 3, 4, 2 squared plus 3 squared does not equal 4 squared, so it's not a right triangle. But if I look at examine their sides, 2 plus 3 is greater than 4, 4 plus 2 is greater than 3, and 3 plus 4 is greater than 2. So these will still make a triangle, right? But they're not going to make a right triangle. So the question that we're going to ask is, can we use the Pythagorean theorem in some way in order to determine what type of triangle this is? And the answer is, of course. Okay. So we have 2 theorems that kind of come from this. All right. So if I look at a squared plus b squared, and if it's greater than c squared, right, That means if I think about the square of both of these two sides and it's greater than this third side, right, then it's an acute triangle. If I look at, which means that this side here has got to be less than 90 degrees, okay? But now if a squared plus b squared is less than c squared, so if I think about this, the square of the sums of these, the sum of the squares of these two, and it's less than c squared, that means c is obviously greater than what it's supposed to be, okay? Because remember, if a squared plus b squared equals c squared, it's a right triangle, right? But if c squared is less than, right, what it's supposed to be, then it's acute. If c squared is greater than what it's supposed to be, then it's obtuse, right? And we know that the measure of angle c, right, has got to be 90 degrees. So kind of just a little table here for you guys, right? So if I'm looking at a squared plus b squared is equal to c squared, right? Mm-hmm. Right, this forms a right triangle, right? If a squared plus b squared is less than c squared, this is obtuse triangle. And if a squared plus b squared is greater than c squared, right, this is an acute triangle. Okay? So this is just a nice little table to kind of help you figure out which kind of triangles that we're looking at, because that's really, this table right here is actually kind of the key idea behind all these Pythagorean ideas. So this is kind of what the buildup of our lesson was today, is to kind of develop these ideas. Okay. So now how can we use them? Okay. So determine what types of triangle the following side lengths make. So if we look at example 1. I have 7, 14, and 16. So this is obviously going to be my greatest side, C, 16. So I look at 7 squared plus 14 squared, which is equal to 16 squared, which is 49 plus 196, right? And how does it compare to 256? Well, 245 is less than 256, so my C is greater than what it's supposed to be, right? So we have an obtuse triangle. All right, number 2, we're going to look at the same idea. So we want to look at, 9, 40, 41. This is obviously my greatest side. So we want to look at 9 squared plus 40 squared. All right, and how does it compare to 41 squared? Okay, well, so we have 81. 9 squared is 81. 40 squared is 1600. And then 41 squared is 1681. Okay. And now hopefully right away you can see, well, 81 plus 1600 is 1681. This is also 1681. So these two are equal, right? So since they're equal, this is actually a right triangle. So this is actually a Pythagorean triple. Okay. Number 3, again, we want to look at, well, what's 10 squared plus 12 squared, and obviously 23 is the greatest side, sorry. And how does it compare to 23 squared? Well, this is 100 plus 144, and then 23 squared is 529. All right, hopefully by now you're actually able to see what this is without actually adding them. So this is 244. How does it compare to 529? Well, 244 is obviously less than 529, so this is actually also an obtuse triangle. Okay. Now, I'm not going to go, so I'm just going to go through example number 1 with this. You can feel free to work on example number 2 yourself. But now if let's just say we're in the coordinate plane, all right, and we're given 3 vertices for this triangle, what we want to do is we want to figure out, well, whether it's right, acute, or obtuse. So in order to do this, what I need to do is I need to find the lengths of all the sides first, okay? Now, I've found the length of AB, BC, and AC, right, using the distance formula. And recall the distance formula, right, is equal to the square root, right, of x1 minus x2 squared plus y1 minus y2 squared, okay? So what I did for each point, So let's just say for AB, I just made this one x1, right, and this one x2. I made this one y1 and this one y2, okay? And so I plugged them into the distance formula, and I found that it was equal to the square root of 8, or 2 rad 2, okay? I did the same thing for BC, and I get that that's the square root of 2, which can't be simplified. And then I did the same thing for AC, which is the square root of 10. Now again, kind of just looking at these three, we have square root of 8, square root of 2, square root of 10. Obviously the square root of 10 is going to be the largest, right? So this would be my biggest side. So now we want to look at, since I found those lengths, now I want to plug them in, or I want to see how they compare to each other. So I looked at AB squared plus BC squared and how to compare to AC squared. Because remember, this AC is my biggest side, so this has to be my C. Okay? Oh, I don't know why they turned orange all of a sudden. Okay? So, or my largest side. So this is 2 rad 2 squared plus rad 2 squared, and does it equal square root of 10 squared? Well, 2 rad 2 squared should, hopefully you should see that it equals 8. This is rad 2 squared, which is equal to 2. And this is square root of 10 squared is equal to 10. 8 plus 2 is 10. So this is actually a right triangle. Okay? And we can identify these out in the coordinate plane. Okay? Just by using these ideas and using the Pythagorean theorem without actually having to graph these. Okay? Anyway, so I want you guys to go ahead and work on number 2. Right, and tell me kind of what you come up with. If you have any questions, please feel free to ask. But I will be posting the solutions with this so you can kind of check your work. But I'm not going to show it in the video. I just want you guys to try to work through it yourself. Okay? All right, guys.